Okay. So we're going to start off by looking at some trig examples, and I know that we've done some trig examples, but I just wanted to spend a few minutes focusing on them. Anytime you have trig functions, I want you to look for, right? If you have some composition going on, which is when we use substitution, okay? Do you see a trig function and its derivative, okay? Because if you see a trig function and its derivative present, we can use substitution, okay? So in this case, do you see a composition with a trig function and that trig function's derivative?
Isn't it just
tangent secant?
Yeah, that's
Dang it, I saw that.
It's tangent secant here. I mean, it's okay if you're not a highly developed. I didn't know that.
Okay, so hang on to that, okay? Do you see the composition?
Yeah.
Okay. Okay, so what would you call u? Because then du is right. So then we would say, all right, we have negative integral 1 over u squared du. Right?
Mm-hmm.
Which some of us may need to write as u to the negative second. And what do we do when we integrate u to the negative second?
Yeah. Why is it? Oh, okay, because you put I was gonna say, how is cosine squared x negative sine x?
Carter, what's the antiderivative of negative u to the negative 2? I'm asking you.
He's like John.
What do we do? What do we do if we have a power? We do what with it?
Oh, that's right.
We raise it and then okay. So what we have is 1 over cosine of x, which is
Shouldn't we factor that negative outside though?
yeah. Okay, we have this negative, but then when we raise to the power of negative 1, we have to multiply by that negative 1. Well, so they cancel out. Right? Now, what Jimmy and Josh noticed right away is that sine over cosine squared is sine over cosine times 1 over cosine. So what they did is they changed, so they did this. Sine over cosine times 1 over cosine, right? Sine over cosine squared. And so they rewrote this to tangent x secant x. And what's the antiderivative of tangent secant?
Secant x plus c. That would have been easier.
Okay, but if you didn't recognize it, was it a problem? No, we can still get there.
It's a long problem.
Isn't that the beauty of math, though? There's not always just one way to get there.
But there's only one way, yeah.
And that might be even more.
That's the one.
Okay, now not all math's that way. Remember trig identities, there wasn't always just one right answer.
Yeah, still.
Okay, let's look at another one. This one's a little more straightforward.
Freezing for that.
Okay. All right. Any ideas about this one?
I just want to change it to 1 plus 9.
So you want me to do this? Okay. But I do see that we have a composition, And so this could be a good candidate for substitution. And what would we want our u to be? Which is convenient, because the derivative of that is, and look at that. It is present in our integral. So we have just u to the 1/2 du, don't we? I might have picked too easy of anything. So u to the 1/2, what is that antiderivative? Don't be mean then.
I was encouraging him.
Wait, were you saying?
Stop. Stop. Yes, he was talking to you. I'm glad that you enjoyed
I didn't even hear that.
Okay. One more trig example. Okay. These past two trig examples, we have used a trig function for our substitution. What? This one isn't that bad though, is it?
No.
Because what do you notice?
It's sine x squared or sine
You should be
squared.
Okay, you see an x squared and you see an x. I'm hoping that you're starting to make those connections. Okay? So we can let u be x squared. Du is 2x dx. Okay. Zach, how would we rewrite this integral?
1/2 sine of u.
1/2 sine of u du. I'm actually kind of glad 50% of you made that mistake, because then you won't make it again, if you're going to remember that.
What about what do we do?
I'm glad that you got it right.
Just keep forgetting that.
Okay. All right, so, Nathan,
Nate, come on, Nate.
1/2.
Negative cosine of x.
Okay, so it ends up being negative 1/2 cosine of x squared.
Oh, she was trying to draw on my
I know.
paper.
Okay. Now we're going to do two examples of what I call incomplete substitution. Okay?
Doesn't sound like fun at all.
It will be that. Okay?
Okay.
Now, every single substitution problem that I have given you has worked out quite conveniently, where if we let u be x squared, there is some sort of x, right? If we let u be x cubed, there is some sort of x squared involved. Now, what can happen is if we have like a linear substitution. What do I mean by linear?
Just one.
It's easy.
Okay, x to the first. Okay, very good. Sometimes we can like have an x left over. Okay, and we need to know what to do with that. Okay, so this isn't the official name of it, but Mr. Griebel and I call it incomplete substitution because we have some left over. Okay, that we have to work with.
It's like a remainder.
Sure. Okay, so in this example, we have a composition. And composition functions is what we really look for in our substitution problems. You agree? That's what I've been kind of hammering the past 3 days. Compositions, okay. So I see the composition, and what is inside the composition?
2x minus 1.
Okay, so we would say, all right, u is 2x minus 1, which means du is 2 dx. You see the problem we're going to be faced with here. We have this x floating around. We have dx that we can substitute 1/2 du for, but we have that extra x floating around. So first of all, let's go ahead and rewrite this. dx becomes 1/2 du, and we have the square root of 2x minus 1. So you want me to write it as u to the 1/2. Okay, but we have that x still. Do we want x's and u's together?
No.
No. What do we do? Okay, we have this relationship right here. Can we write x in terms of u? We sure can.
2 plus 1 by the way.
We can add 1, divide by 2, and then that would solve for x. No, we're just going to have to do a little bit more rewriting. So what we have is 1/2 the integral of u plus 1 over 2. That was not a 2.
How'd you get the u plus 1 by the
Okay, so over here, we took this relationship and we solved for x. So add 1, divide by 2, and that gets us x. Okay? So now we have this.
We're done.
Okay, so first of all, this 2, it's a constant. Can we move it outside? So I'm going to make this a 1/4. And then we just need to distribute this u to the 1/2. So 1/4 is outside, and now I'm going to write u to the 3/2 plus u to the 1/2.
What'd you do with the 1?
Because you still have a leftover
U times U 1/2. You add x line.
No, but how'd you get to the 1/4 number again?
I took this 2 and just moved it outside.
Oh.
Because it's a constant. Constants are easier to work with at the end, so we can just throw them off to the side.
So then you can add those, so you get a...
We cannot add those. We cannot add those. Because they're not like terms. Okay? But like we can't add x squared and x cubed.
I was thinking common denominator.
It's okay. Hey.
All right. Now we can actually do our integrating. Okay, we've done a lot of prep work. Now we can actually do it. So we're going to have 1/4 times u to the 3/2 becomes,
U 2/5 U.
okay, increase the power,
Plus 2/3.
multiply by the reciprocal, plus 2/3 u to the 3/2
Plus C.
plus c. Okay, so now let's worry about that 1/4. So 1/10 u to the 5/2 plus 1/6 u to the 3/2. Are we done?
Yes. Oh, the U's gotta come back out.
Okay, we don't want those u's. That's gotta come out. So we have 1/10 times 2x minus 1 to the 5/2 plus 1/6 times 2x minus 1 to the 3/2 plus, and that is the answer that I want.
And then are we gonna have to do in the stuff we did beforehand to find number for C?
What?
Are we have to do, or we have to combine all, we're given something, you have to find C.
I don't know if I have any of that for this homework. No.
Good question.
And I'm trying to think if that is on your quiz or not. I'll have to look. I think it probably is.
You can always take off next year.
Because it was such a hard concept.
Well, that's why they invented whiteout.
That's why they invented what?
Why not?
Have you ever had someone try and do that to someone? Where they try and white out like a question and stuff?
It's never on my test.
You know, like on a quiz or something, if you don't know the answer, some kids just like white it out.
That's a thing. People do that.
I did that once on a Spanish thing. The thing was sun and I didn't know what to do, so I wrote day after it and I put that.
Put the day after.
Like Sunday and then
Yeah.
And then you're like, why does it say Sunday?
last example, and then I'll give you some time to practice. I'm gonna now be very careful when I grade your quizzes.
And there's things that like bird teachers are.
Okay, and if you're gonna use whiteout smells, I'm pretty sure I would notice it.
Yeah, you can totally see it.
Yeah.
There's a picture on Twitter, like the teacher wrote back, you can't use whiteout on a
I'm glad you were trying to be creative. Okay, so I see a composition. Do you see a composition?
Yeah, it's on the bottom.
Okay, so what would we let u equal
X plus 4.
to? X plus 4, ooh, which this is nice, du equals dx. Okay, so then we would say, okay, well this is dx becomes du. We have square root of u in the denominator, and 2x plus 1 is really 2 times x is the same thing as
U minus 4.
you okay with that? Everyone see how we got the u minus 4? Yeah. Since u is x plus 4, then x is u minus 4. With me? Okay. Okay, so the numerator is 2u minus 7, and that's really being multiplied to u to the negative 1/2, right? That's really how we want to write it. Okay. And then to rewrite this even more, what would we want to do with that u to the negative 1/2? What? Okay, distribute. What did you say? Okay, you said it really fast. So what is u times u to the negative 1/2? Minus 7u to the negative 1/2. Okay, so we have 2 times u to the 1/2 becomes minus 7 times
Negative 2? No, 2.
2u to the 1/2. So our final answer, 4/3 x plus 4 to the 3/2 minus 14 x plus 4 to the 1/2. Now, like I've been saying, you can take your answer, take the derivative, and check your answer. When we have these incomplete substitutions, that's not a very easy process, okay? Because taking that derivative and then simplifying it down to one fraction might not be what you want, might be more work than you want to do. So just be careful.
So you're just saying, so you just told us to be late.
No, what I'm saying is you might not want to do that or have time to do that in a quiz type situation. Have you been checking your answers by taking the third quiz anyway? Okay. So I would like to give you some time to work. So I guess we have like 10 minutes before announcements start, but then you have some extra time with announcements. So here's your homework.
Why doesn't it just say 33?
I don't know. Because I assigned by chunks, and I wasn't gonna put these two chunks together originally.
I mean, Aaron doesn't have,
Yeah, it kind of does.
makes it look shorter, so then maybe this class isn't for you.
Maybe the class is for you. It's not.
So much hostility in this classroom, I imagine.
Jimmy's a bully.
Because I get it from you. I go stand up.
Oh, there is a couple of those. Okay.
Wait, which one were you at? C?
Where you like?
Yeah,